So let's look at how we would simplify a radical that has a number part, coefficient, and a variable part as well. We start with this rule, this basic rule that says you can split up a radical that multiplies to something into the two separate radicals being multiplied together. So our goal here is going to be to think about what part of 50x cubed is square rootable, meaning what part of that can we take the square root of and actually get something nice, no decimals, and get a nice whole variable component as well. So specifically, we say that that first radicand, the part that goes under the first square root, needs to be a perfect square. Now, perfect square is a number that is obtained by squaring another number. So you might think of, well, we could start at 1. 1 squared is 1. 2 squared is 4. 3 squared is 9. Now keep the perfect squares going. After 9 comes 16. After 16 comes 25. Now, 25 is relevant here because 50 can be written as 25 times 2. So that means we can split up square root 50 as square root 25 square root 2. That is the same numerical value. Now the nice part here is we know what square root 25 is. That's just 5. Okay, so we would be done saying that's going to be 5 root 2. But notice something here. I'm not going to split it up as square root 10 square root 5. Okay, so that the reason I'm not going to do that is because square root 10 is not a whole number. So I can't simplify it any further here. So we have to be strategic. We need to split up our radicals so that we can take the square root, or cube root as it were, of that first radical expression. Now here's my first step then. I'm going to take out the 25 from the 50, and I'm going to take out, think of it this way, I'm going to take out that x squared from the x cubed. Okay, because x cubed can be written as x squared times x. Now the x squared part we can square root. When you square root x squared, you just get x. But that x part, it's kind of like that too. So it's going to sit in there in that second radical with the 2 because we can't square root that. We can't simplify square root x. Square root x is just square root x. So the strategy is we always take out the highest even degree variable term. So again, x cubed, as we would write it as x squared times x, because x squared is the highest even degree. We put that first. Now, this is just an example, okay? So this is not directly related to this question, but suppose we had square root of m to the power of 7. So we'd split that up as two radicals. Notice that m to the power of 6 times m multiplies to m to the power of 7. And m to the power of 6 is the highest even degree exponent of 7 that we can take out. So I'd simplify that as taking the square root of m to the power of 6, that's m to the power of 3. And again, that's just because m to the power of 3 times m to the power of 3 times itself takes me back to that m to the power of 6. And this is considered simplified. So we would not want to write square root m to the power of 7. We'd want to write m to the power of 3 square root m. Even though it's longer, it's considered simplified because we've taken the square root of what we can. Let's go back to our expression. So we note again that the 25 times 2 multiplied to 50. 25 is a perfect square. So that's the number part. We've got our variable part, and now we take the square root of the whole thing. So square root of 25 is 5. Square root of x squared is x. And again, that square root 2x can't be further simplified, so we are done.